Just a moment, I need to check something. Do you hear me?
Hi, hello.
Hello.
Good morning, good afternoon, everybody. We are now 4th day of our summer school, and today we have with us Vinko Zaninović, our assistant professor. Hello, Vinko.
Hi.
Hi, okay. Are all students here, yeah? Most of them.
So I hope that you managed to see a presentation that was sent to you yesterday. Sorry. So the first task was that you create free account on our cloud. Have you managed to do so? Because it will be easier to follow this workshop if you have this account. So our studio cloud, I'm writing here in chat. Okay, so please open it, because I will share my screen in our studio more than presentation. So do you see my screen now? Okay, excellent. So first, I know that, so you need to write in the chat. So first, have any of you has any experience working in R? Or have you ever heard about R? Okay, Yanis, yes, okay, excellent. So I have one yes. Yanis, okay. So please write to all panelists and attendees. Okay. Have you ever worked? Have you ever did some data analysis? So data managing. Have you ever tried to extract some informations from some data? SPSS, yeah, Devrim. Data scraping, yeah, okay. Yeah, okay. Yeah, okay. So then I will just go back to presentation. So this presentation is all about how to extract data using R and RStudio, and how to extract data, so particular data from World Bank and Eurostat. First I will talk a little bit about motivation, so why we want to do that, and then we will start actually doing it in R and trying to get the data, to obtain the data and manipulate them so that we can extract some informations. Okay, and finally I will give you your individual assignments and a group assignment. So first, about motivation. So we always like to know, so what is behind the corner, so what awaits us. Sorry, Robert Silconi, Windows or Mac laptop. I think that it is the same, because for our cloud only browser matters. So if you asking whether you will be able to follow this lecture workshop using Mac, I think that everything is the same. Yeah, just if you if you can open it, if you can open our Studio Cloud in a browser, then everything is okay, because this is the main thing that you should be able to do. Everything else is completely the same, whether you are on Windows or on Mac. Okay, so people, we always want to know what will happen either tomorrow or in 1 week or in 1 month. So and usually if we want to give some educated guess, so if you don't want to speculate, but if you want to give some educated guess, we need to use some quantitative methods. So usually if you want to forecast the outcome of some football match or something like that, we will use usually question. Yeah, the idea is that you make your free account on our Studio Cloud, and then you will follow what I'm doing, and I will explain what particular commands are used for, and so on. Okay. Yeah. Okay. So, for example, if you want to try to forecast, but to make some naive forecast about the outcome of some football match, what we usually do, for example, if Manchester City and Liverpool are playing, and they are playing tomorrow, and we want to make an educated guess, so what pieces of data will we use in order to forecast this the outcome of this match? So what people are usually doing in these cases, not only for football matches but in general, but in this example, the example is for football. Yeah, but you speculate, but you use some what is the basis? Yeah, this is so what Devrim wrote, and you analyze past outcomes. So you will take some historical data, and then you will see out of, I don't know, last 10 matches or football games, Liverpool won 7 times, Manchester City won 3 times, and then on base of that you will try to give your opinion who will win on tomorrow's match. So usually quantitative methods use historical data, and then we use this historical data in order to forecast future data, and we use them through math and statistics. So we apply math and statistics to historical data, and we create some mathematical models, and then we use them in order to explain past events and forecast future events. And obviously the goal is so not only to explain past events and forecast future events, but also to guide our decisions, whether these decisions are on personal level, firm level, or government or country level. If you want to use these models, first thing that you need to do is gather data. So you need to gather and sort the data, and then you can start doing data analysis. So this will be the goal of today's workshop. So we will try to gather data and analyze some macroeconomic data. So you will see that everything will be on country level, because it is this type of data is easy accessible, and you will see that if you want to so in future, if you are interested into this topic, then you will see that it is very difficult to find individual or firm level data, because usually you need to make some surveys, some questionnaires. So you need to use this primary sources of data. So today we'll only cover these secondary sources. So these are the data that someone else already created, and then we just use them in order to find or to get some new insights out of this data. Okay, so a note before we start: this presentation is to be used with EFRI SS 2000 20. So I send you this, or my colleagues at summer school, they send you this file together with PDF and one comma separated values type of file. So now we'll skip to RStudio, and for the rest of the more or less for the rest of the class, we will use RStudio. We will go back to this presentation for the assignments part. Okay, so now I'm opening my R Cloud. If you have any questions, if you didn't hear me well, if you have any opinions and so on, just write in the chat or raise a hand so I can. I will stop and explain again, or I will give more. Thorough explanation if this is needed. Okay, so if okay. Question: how do you open a file? So if you have this in your on your screen, then and if you downloaded this EFRI SS 2020.r file, you just go to File and Import Dataset. Or no, sorry, this is one way. It is easier to go here. So on this right portion of your screen, you have this Files, Plots, Packages, Help Viewer. You go to Files, and then just click on Upload. And then you will choose a file. So this is my, for example, my downloads. And then here in downloads, you, for example, in my case, I can, or in my case, actually, I think it is here, yeah. So here it is my FreeSS 2020.r. Okay, so just to repeat, on the right portion of your screen, there is a Files, Upload, and then choose File and look for it on your desktop or downloads. I know where you downloaded it. Okay, Devrim, can you send me how your screen looks like? Just take a screenshot and then send me in a chat. Okay, and Anna, I will send you mail. Just a moment. Just a second. Okay, Anna, you can just refresh your mail. You will see these files. Yeah, you need to press new project, but so you can send me then on my email. So I will go back to, so I will log out just to see. So you can follow me, you can try to follow me again. Okay, so do we all have this screen that I'm showing you now? because so this is where you so this is the screen that you get when you click when you go to our cloud. I think it worked. Okay, it worked. Okay, so then I will just log in again. Okay. So are we now on the same page? Anna, did you download the files? Because I sent you an email. Okay. Are we now on the same page? Do we have? Yeah. Okay, Daniela, just a moment. Just a moment. Okay, I send you the mail. So can we just start again? So can we try to open this file? So as I said, you go to upload, choose file, then you choose your EFRI SS 2020. So I sent, yeah, just a moment. Because tomorrow I send all the files. Just a moment. Okay, now I send you Lee. So I send you the mail with the attachments. Okay. So can we now start or restart? Okay, so I hope that we can. So if you manage to upload it, so upload, choose file, and so on, then you will get this file here. It will be in your files, and you can just click on it. So FRSS 2000 or 2020, sorry, and then it will open here. Okay. Did you manage to do so? So yes, okay, 1 yes, 2 yeses, more, at least 50%. Okay, more yeses. No, Anna. So where do you have problems with uploading, or have you managed to? If you downloaded the data that I sent you, okay, with uploading. So have you managed to find this? Okay, I think. Okay, so first, when you download the data on your, so when you download the files on your desktop, so you have 3 files. One is CSV, one is PDF, and one is R file. So this is the final FRS 2020 that we talk about. And if you downloaded them on your desktop or in some folder on your computer, you just need to remember where you downloaded it, and then you just upload files to server. Just a moment, I have one mail here. Just a moment. Okay, now I sent another mail. Okay, so let us try. You will have this, everything is recorded, so you will have this this video available to you. So if you didn't manage to open this file, never mind. We will go through this all these commands now. So the point of this R file is that you have everything in one document, so that you can more easily solve your assignment, individual assignment. So don't worry if you didn't manage to open this R file. It is important that you have this console open here. Okay. So now we can start. How do you operate in R? So first, you see here that everything in console is empty right now, and here on the right portion of your screen there is a message: environment is empty. So you can see here that you have some global environment, and that we don't have anything in it. So everything that we will create will be here in this global environment. And every plot, so every graph that we create will be here in this plots part. So here I have something from before. So I will remove it. I will clear all plots. So this is something that you have right now in your screen. Okay, on your screen. So we can start. We said that everything that we worked today is all about data. So data gathering, data managing data, and finally we will try to describe some data and to explain some functional relationships between two sets of data, and we will call them variables later, but we'll get to that. We'll get to that. So first thing, we want to create some simple data, and we will call it, in order to do so, we will create some object. I will call it data. So this will be the name of my data. And you can see here that I'm writing, so this is just like equality sign in mathematics. So this arrow and this line is just like equality sign in mathematics that is used in R. And I will create some vector, so some numbers from 1 to 5. So do you follow me? So I want at least 7 yeses. I have 2 yeses. So majority 4, 5. I'm okay. I'm satisfied. Okay, 8 yeses. So we can continue. So now when I click enter, you can see what happened. So we have global environment is not empty anymore. Now we have some data, and this data is from 1 to 5. I can write data here again. And if I write just data, then R will give me what is hidden behind this data text. So remember this, everything that you create in R, so everything that is on the left hand side, so this is the left hand side, this is the right hand side, everything that is in this left hand side text is called an object. So this is an object. The name of this object tells us that there is some data in it, but the most important thing is that this is some object. If you are more familiar with this with programming, then you will see that there is something that is called object-oriented programming, and R is something. R is software that uses this object-oriented programming. So have you ever heard for this OOP? So object-oriented programming. No? Okay. So again, never mind. For the purpose of this workshop, this is just an info. It is not. You can live without knowing what object-oriented programming is and where it is mostly used. And here again, I will show you the same kind of the same kind of object creation, so I will show you that there is all in R. There are always more ways to create some object or some data. So I will now create data 1. And this data, in order to create this data, I will use some function. This function is called sequence. And if you see what is happening here, when I wrote SIQ, then R gives me options. So it gives me some explanation. So everything that you see here, these are potential functions. So I will just highlight this. Not highlight, but just a moment. Okay, and if you look, if you click on F1, then you will see that automatically help window opens, and here you can read more about this function called sequence or sec. So, and here we have the examples of usage. So how to use it. So these are examples of how to use this function. So obviously, for the purpose of this workshop, you will not need to read this, but this is just in case you are after this workshop, if you are interested into R, then you can use this workshop as a base for future education about R. So I will create some sequence of numbers from 1 to 5, and I will press enter. Now I have two data sets. One is called data, another one is called data 1. And now I can check whether these two are the same. So if I want to check whether these two are the same, I use logical symbols. So these are two signs of equality, and I will just ask R to confirm that these two sets are the same. And obviously they are the same. So why why R repeated 5 times the same thing? Because R, since these are two vectors, so data is a vector, data 1 is a vector, then R checks whether the same numbers are on this in the same positions in these two data sets. Yeah, for each vector. So in each vector, you need to have the same number in the same place, and then they will be equal. And this is what is happening here. So they are equal. So we are informed us that both of them are completely equal, and we can use one for testing purposes, for example, and another one can be kept just as original in original form. You will see why this is important later on. And finally, so these are two pieces of data, and we wanted to create one unique data set. So I want to create a data set that will have two variables. So in order to, so since these two pieces of data are the same, I will create another piece of data. So I will now create data 2. Data 2 will be some number, some random integers. So I will tell stat R to create some random integers. And for example, I will tell R, just a moment, I saw that someone is writing. No, so I have a question, so I will just repeat it here for everyone to see. So this is the question that I got. You don't need to follow the rules for spacing. So, okay, so I can write here, I can write this, everything will be okay, okay? It is more, it is nicer to write, to follow some rules, but you can do it like this. And so what I'm telling R here, I'm telling R that I want R that I will give the order to R that among 10 numbers from 1 to 10, I want that R picks 5 numbers. So X will be some number, or will be some numbers from 1 to 10, but I want I only want 5 numbers. And if I click yes, or sorry, enter, then you will see here that R created some random numbers, and I can do the same command. I can repeat the same command, and if I repeat it, then you will see that now I get another 5 numbers, and if I repeat it for the third time, again some other numbers. Okay, so how many so every time that I repeat this command, the numbers are new, so they are just rewritten in the same data set. Okay, and if you remember your statistics class, you will see here that this sample function is used for sampling without repetition. So this means that you cannot have the same 2 integers in this data set. Okay, so what we want to do now, we want to create a data frame, and this will be the keyword for today. I will write it in a chat. So the keyword is data frame. Okay, so data frame consists of at least 2 columns and many rows as you like. So, but the point is that you need to have at least 2 columns. And now we will see how this data frame looks like. So I will create a data frame that will be called data set. So data set will be equal to, so data frame is actually a command or a function in R, and my data frame will have 2 columns. One column will be data, and another column will be data 2. Okay, and now when I click here, yes, now I will have data set. So you see now that there is a different different type of data. So we just created a different type of data. So before we only worked with values, so we only worked with vectors. But now when I use this data frame command, now I have a data, and this data has 5 observations of 2 variables. Okay, so this is the important difference with respect to what we did before. So now we don't have some random vectors or some vectors that we just created, like using this sequence from 1 to 5, but we have variables. And moreover, when we have data, here you have this this rectangle, and you can click on this rectangle and you will see your data. So please click on it, then you will see that a data set is now in front of you, and you can check your data. And this is the same as in Excel. So you can see that the data structure is the same as in Excel. You have columns, so column 1, column 2, and you have rows. So in this case, 5 rows for 5 observations. So in R and in SPSS, in Stata, in every other software of this type, you always have observations in rows and variables in columns. So you can switch these things, you can translate them, but usually this is the usual form. So rows contain observations and columns contain variables. What I want to show you next is how to rename them, because data is not so informative. We want to know what is within this data. So I will use a function called names. So data set, and now I will give some names to my data. I will write the following. I will write first will be consumption, and the second variable will be income. Okay, when I click enter, then you will see that now I don't have data and data 2. I have consumption and income. So this command here is used to name your variables. So now the question is why I just renamed them consumption and income. So we said that we want to gather data, so obtain data, then manipulate data, and finally we want to get some insights out of this data. So imagine that you have some questionnaire or some survey, and then you ask people for their monthly income, and you ask them about their monthly consumption. And imagine that these numbers are thousands of euros. So for example, for this first observation, so we have some consumer 1, and his income, monthly income, is 8,000 euros, and his monthly consumption is only 1,000 euros. So the second consumer, he earns 10,000 euros per month, and he consumes only 2,000 euros, and so on. So imagine that you have this kind of data. So what are do you have any idea what can we what insights can we, or what conclusions, or what questions can we ask ourselves from this type of data? So do you see any potential functional relationships between, or relationship between income and consumption? Okay, I'm writing average consumption in income groups. Yeah, okay, this is a good first idea. So I can look, so obviously here I have only 5 consumers, but for example, if I had a data set of 10,000 consumers, then I can see what is the average consumption per consumer for consumers that earn, for example, 10,000 euros. So imagine that I have, I know, out of these 1,000 people, I have 100 people who earn 10,000 euros per month, and then I can see what is the average consumption for these people who are earning 10,000 euros per month. Okay, another idea. And what Darren just said, this is something that is called descriptive statistics. Okay, so when you calculate means, modes, quantiles from particular variables, then you are describing the data, and this is called descriptive statistics. So I can, for example, I can even plot the data. So, and this is also part of descriptive statistics. So here, if I write plot, for example, no, I will show you this later because it will be it will be too much right now. Okay, so we will get later to that. But I will now give you one more idea what you can do with this data, and this is establishing a functional relationship between consumption and income. So if you know the theory, wait a moment. So Robert is writing something. We can see how many people are living higher than their possibilities, and we can calculate savings for the rest of the people. Yeah, okay. Yeah, Engel's coefficient by country. Yeah. So from microeconomics. Yeah. So this is so Kim, he wrote. Okay. So this is what I also get as an idea. But the simplest idea is called regression of consumption on income. So how many of you heard for this term regression? Or linear regression? So have you ever heard for these terms? Okay, so in this case, I can write that consumption is a function of income. Do you all agree that consumption is a function of income? So if income increases, then consumption will increase. So this is what theory, microeconomic theory tells us. Okay, so if I want to, and your group assignment will be, so individual assignment will be descriptive statistics. So each of you will need to calculate some descriptive statistics for the variable that I given to you, while the group assignment will be descriptive statistics plus linear regression. But we will come to it in a couple of moments. Okay, so until now, now we know how to create data, how to merge two different sets of data, and how to name them. And now we want to describe this data. So we want to calculate some statistics. So how to do this in R? We will do this with the function called summary. Okay, summary. And you can see here that explanation of this summary is that it gives us the analysis of a variance model. It can give us that, but we will use this summary default. So summary default is a generic function that is used to produce result summaries of the results of various model fitting functions. So in this case, we will not fit any model. We will just calculate simple statistics, so mean, median for these two, and quantiles for these two variables, consumption and income. So summary data set, because I want descriptive statistics for both variables, and then I will get my data. So do you all have this in front of you? So consumption, income, do you see this? Yes, okay. One yes, two. No, two yeses from one student. Yes, okay. So look here. What are the problems with why you don't have this in front of you? Seung, sorry if I wrongly pronounce your name. You follow, okay. So the question, if you lost, so just repeat the command. Okay, summary data set. So this is my answer to Park, okay? So summary, and then in brackets, you just write the object. In this case, my object is data set. Okay. And now look what we have here. We have a range. Why a range? Because range is difference between minimum and maximum. So minimum value is 1 for consumption and maximum value is 5. So we know that the range is 5 minus 1. So the range is 4. And the same thing for income. We also have first quantile. We have median, mean, third quantile. And so these are basic statistics that we use when we want to describe our data. And if you want to, so we said that everything that you create on the left-hand side is an object. So this means that you can enter this object in R, you can enter this object and tell R to give you some pieces of information only for one column, so only for one variable. So for example here, if I go to my data set, and if I want to enter this object and tell R to give me only data or only descriptive statistics for consumption, I will use a $sign. So $sign, and then you can see that by default, R gives me 2 possibilities. So either consumption or income. Why? Because in this object called dataset, I have only 2 variables. So I will choose consumption, I will press enter, and then I have only descriptive statistics of consumption. You will see that, again, this will be important when we go to World Bank and EUROSTAT data. Okay, so this is a summary command or summary function that is used for descriptive statistics. And now this part is particularly important for my group. So the first group who needs to do a regression analysis. So how to do regression analysis in R. So I will write here in a chat regression. So simple. I will write simple because this is the simplest case. Simple regression analysis in R. Function is called LM. Okay. So how to do regression analysis in R? So we said that we already said that consumption is a function of income. So I want to estimate the following linear equation. So I want to estimate, I'll write here, that consumption is equal to some constant. I will call it beta, so Greek letter beta, beta 0, because this denotes constant in my case, plus beta 1 income, and plus some error term. Okay, so this is the simplest linear regression model. Okay, and this is the same thing as in mathematics when you have y is equal to 2 plus x. Okay, so this is the same thing, but this is deterministic. Why? Because we know that that this function will give us some straight line, and that every point will be on this line. So every point in the data set will be in this line. But here, since we have this error term here, we know that we will get something like that. So we will have a lot of dots, and we will have some line that will go through these dots. So this is the main idea behind regression. And now I will show you how to do this. So how to estimate this line in linear regression model by using linear regression. Okay, so I will create an object that will be called reg, shortened for regression, and I will use my function lm. So lm, and first I will write consumption, because consumption is my dependent variable. So dependent because it depends on income. So consumption, and income is my independent variable, because it is given, and so it is so income is called independent because it is given in this model. It is not explained by the model. So only variable that is explained by the model is the consumption. And finally, data. My data here is called data set. So this thing here will create an object that will be called reg, and then we'll be able to see what is the functional relationship between income and consumption. Okay, so now you can see here that reg is a list of 12 values. You can check if you click here on this magnifier. You will check what are these values, so coefficients, residuals, and so on. So we are not interested into them. We are interested into this. I will again use summary function, and I will put an object here called the reg, and then I will get my results. So results of linear regression. So if you remember, this is the thing that we entered, and then these are the results that we obtained. The most important thing here is these two pieces of data. So this is my beta 0. So this is beta 0. This is constant, and this is the slope of my function. So this is the coefficient of income. So this is the number, or this value tells me that if the income increases by 1 unit, then the consumption will decrease by 0.13 units. Question: how many of you know or have listened to some course where you mentioned linear regression and where you estimated these type of functions? So do I need to repeat something here? So how, for example, how can we how I interpreted this number and or something like that? Okay. I will write it. Just a moment. I will. So this is. I will show you this example. So first, I will just go a little bit back in order to explain things on another way. So look here. Just a moment. Type. So you don't need to write this. I will just. Okay. So what I just created here. So do you all agree that this is a linear function? Yeah. Okay. So this is a linear function, and I just add something to it. I will just say that x is actually x, or I will say that it is income, and y will be consumption. And the title will be example of linear function. Okay, so imagine that we had this situation. So we interviewed a group of people, and we asked for their income and for their consumption. And then the first guy, he told us that he earns 1,000 euros per month and he consumes 1,000 euros per month. Then the second person arrived, and she told us that she earns 2,000 euros per month and she consumes 2,000 euros per month, and so on and so on. So we had 5 people or 500 people or 5,000 people. The number is irrelevant for these purposes. But the point is that they all consume everything that they earn. Okay, and if this is the case, then if I connect these lines, sorry, these dots because just a moment. Imagine that we just wanted a scatter plot. So if we have, so this dot here represents one consumer who earns 2,000 euros and spends 2,000 euros, and so on. So if I want to connect these dots, I will get this thing here, and this is some linear function. And how can I interpret this linear function? So how can I interpret the slope of it? So what this slope actually tells us? So if I want to write mathematics, so y is equal to x, or in this case, consumption is equal to income. So do you all agree? Do you agree that this is the case in this example? Yeah, okay. My question is, so this is consumption, I will write it fully. The question is, where is the constant here? Here I'm missing a constant. Why? Because constant is equal to what? In this case. So the constant is, in this case, the constant is equal to which number? No. Because so this graph ends here. It ends here because I didn't give him the enough space, so I can write here, yeah, 0. Yeah, 0. Because just a moment, I will show you. Yeah, it did not work here. Yeah, never mind. But it is 0. Okay, why it is 0? Because we this line tells us that we earn that we spend everything that we earn, and if we earn 0, then we will spend 0. And imagine now that we have a different situation. So imagine now that we have data and data too. So that we have data 2 on x as income and data. So imagine this situation. Do you all agree that there is something different now? And if I go back, if I use this dot notation for my data, so now I have different scenario. Why? Because in this situation, I have 5 consumers, but you will see here that it is impossible to connect these 5 dots or circles with one line. So I can only use some non-linear function. So I can connect them like this. So this is like some kids drawing, or I can connect them like this, and so on. Okay, but it is impossible to use a straight line. So, and my goal is to use straight line in order to explain connection between income and consumption. Okay, so how can we do so? We can do so by estimating an equation, so linear equation that will try to limit the errors. Just how to. So we will try to tell R to draw a line that will be, just a moment. So to draw a straight line between these numbers, and in such a way that this line limits the distances between this observation and this linear graph or linear function. Okay, so the idea is that these distances, so these vertical distances, are the smallest that they can be, and this is what ordinary least squares method is actually doing. So ordinary least squares. So have you ever heard for this OLS? So acronym is OLS. Have you ever heard for this method, this estimator? For Croatian, for Croatian participants, maybe they will be more familiar with metoda najmanjeg kvadrata. No, okay. So never mind. The idea is that we want to keep things linear. So we want to see where is how strong is linear connection between income and consumption. So never mind that we don't have any lines, any dots that are on the same line. We want to be able to estimate a linear function. So this kind of thing that minimize the errors that we will make, and these errors are actually differences between observations and this dots. And one more thing that is needed here. So imagine that you have equation like this: y is equal to 2 plus 2x, and if you want to draw it, so what do I need to draw this function? So I need at least 2 numbers. So I will try with x is equal to 0 and x is equal to 1. So I'm just drawing first quadrant. Okay, so if x is equal to 0, then y will be equal to 2. So here, so this is coordinate 0, 2. And when x is equal to 1, let's say here, then y will be equal to 4. So imagine that this is here. So this is my second coordinate that will be equal to 1 and 4. Okay, and if I know these 2 points, then I can draw this line. So do you all agree? Do you all remember from high school that this is the way how to draw this linear function? So this linear function is equal to y. So y is equal to 2 plus 2x. So do you remember this? Yeah, excellent. So I have 2 yeses, or 1 correct and 1 yes, but I think that you all remember this from high school. And do you know, so now we know what this 2 is, and we know what this what this other 2 is telling us. So this 2 is the constant. So this 2 is this thing here. Okay, so this is the constant. And can you give me the answer to this question? What is this second number 2 next to x? So what this number 2 is telling me? It is coefficient, but this is also coefficient, but this is coefficient for the constant. But this is coefficient which tells us what? Yeah, the slope. So if x increases by 1 unit, how much the value of this function increases? So if x increases by 1 unit, function f increases by how much? By 2 units. Okay, so this is what this number is telling us. So if argument of this function, in this case x, is increasing by 1 unit, then the function f with the point, so this is a function called epsilon equals to 2 plus 2x, will increase by 2 units. Okay, so if this is 1, if I go from 1 to 2, so if x goes from 1 to 2, then this number, now this is 4, and now it will be 5. Okay, so this is what this linear equation tells us, and this is what we will want to do, or what you will need to do for your group assignment. So my group that needs to do this first assignment in this workshop, but more about this later. Okay, so this is the idea behind linear regression. So in real life, we said that we don't have the situation that all the points are on this line. So in real life, we will have some points that will be here, 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 and here. But again, we will want to draw a linear function that best explains how x variable affects function, or in this case, y variable. So the value of the function, or in this case, y variable. And if we want to go back to the results, so the results of our, I will leave this. So if you want to go back to the results of my regression that I show you at the beginning of this story, so here, so this regression, you can see here that in our example, this 2 was not 2, but it was 3.86, and this 2 was not 2, it was minus 0.13. But the explanation is completely the same. So if income increases by 1 unit, then consumption will decrease by 0.13. And if these units are in thousands of euros, then I will say that if income increases by 1,000 euros, then the consumption will decrease by 131 euros. Why? Because everything is in thousands. So I multiply this by 1,000 and I will get 131 euros. So this is the idea behind linear regression. So this is completely simplified, but it is correct, and you will use this when you will do your assignment. Yeah, this is the elasticity actually. Yeah. But in this case, if you want to give the best answer, it will be called elasticity when you take logarithms out of both income and consumption. So then you get so-called constant elasticity model or constant elasticity substitution. But you will. But this is this is it. So this is the elasticity of a function. Yeah. Okay. So we can now go to World Bank data. So now we know what is the data set. So we know that data sets in R are presented by data frames, and in data frames we need to have at least two columns. We have these two columns, and now we want to obtain data from World Bank. And for those of you who managed to open R file, so we are interested into row 35. So we will not install row 32 and 33. I think that we will be able to do it without it. So we will just install two packages that will help us call data from World Bank server. Okay, so let us try to do so. So in my case, it is already installed, but you will need to install it. So you will need to install this. So either write this thing here, or you can just, so those of you who have managed to open this thing here, so who managed to open EFRI SS, then you can just go to row 35, highlight it, and then press run. Okay, and then automatically this package will install. And don't so when you press run, or if you wrote here in the console, then you need to wait until this now it has gone, but you need to wait until this stop sign is visible, because when you see a red stop sign, this means that R is working, so that R is installing something. Okay, so when you install this package, then you need to it will be, everything will be everything is recorded, and everything will be available to you after the class. But I will give we will arrange some meeting later. So I will give you we will have consultations in I think that the Monday will suit you most, and then you will be able to ask me some questions if you have problems with your individual assignments or group assignment. Okay, so but we will arrange this at the end of the class. Okay, so when you install this package, now you need to open it. So you can just again highlight it here and press run, or I will just write here library. Sorry. I'll just copy paste it. Okay, library. Okay, so now we have this WDI is acronym for World Development Indicators, but these are all indicators from World Bank. And now, if you look here, this is again on the left hand side, this is some object, so you can write here anything so I can write here data, or I can write here everything that I want, so it is not relevant. So this is the name of future object, but it is important what I write at the right hand side. So this thing here, you will need to use it for your both individual and both group assignment. So remember that this row 38 is particularly important for you, because here by running this code, you will access a particular pieces of data. In our case, so we will just try to run this, and then we will comment what we obtained. So just click on run, or I repeat, if you didn't manage to open this R file, then you can just write this here. And now you can see what is happening in our environment. So in our environment, we have a new object that is called WDI dat, and we can see here that this is some data that has 15,840 observations and 11 variables. If I click on it, then you will see that actually this acronym SH and so on, this is an acronym that stands for current health expenditure as a percentage of GDP. And we can see here that we have a bunch of data from every country and every region in the world. So you have this Arab world for starters, this is aggregate level, but we have data for countries. So Andorra, for example, and we can see in the case of Andorra, what was the current health expenditure as a percentage of GDP from 2013, 14, 15, 16, 17, 18, and so on. Okay. So this is a way to obtain data from R. And if you don't want this aggregate, so if you look at the beginning, we have some aggregates, and if you want to eliminate them, then you have this another piece of code. This is row 42, and you have here explanation. So this line of code removes aggregates. So I will just run it, and you will see here that now I don't have 15,000 and something observations. I have only 13,000. I click again on it, and then you will see that I don't have any Arab region, South Asia, Europe, and so on. I only have countries, and you can filter here, and you can search for your country. So for example, Germany, so you have data from Germany. You can search for Croatia. So, and not only that, you have data for the expenditures on health in GDP. You also have some general data, so capital, what is the geographical position of capital. You also have data regarding income, so whether we are in low, middle, or high income group. So you can see here that Croatia is in high income group. The same thing for Korea. So I think that yeah, Korea Republic, yeah. So here you have the data for Korea and so on. Okay. Have you managed to follow me? And have you managed to open this World Bank data? Yeah. Okay. So now for example, your individual assignments will be descriptive statistics of this kind of data. If you go back, so I will go back, you can stay on RStudio. In RStudio, if you look at your data, individual assignments, so what will be your assignment? You will need to do a descriptive statistics of World Bank data. So here you have the title or the name of this particular variable, and you have the acronym And this acronym is important because if you see here, if you go back on RStudio, you can see here that you will just need to replace here the right acronym, and then you will get the data. And when you have the data for the individual assignments, here you have solutions. So this is the function that we already mentioned. So this is a function that gives you descriptive statistics, and you will need to just need to explain or comment the mean and quartile. So what they are telling you, and that's it. So one sentence is enough. And now I will explain a little bit more this statistics. But the most important thing for the individual assignment is that you know how to extract data, that you know how to eliminate aggregates, so that you are left only with countries, and then you can calculate descriptive statistics. For example, in our case here, this row 52 will give us quantiles. So you can see here that we have first, second, third quantile. So first and third are the most important ones, and this second is also called the median. And can someone explain what, for example, this first quartile or 25th percentile, what this number is actually telling me? So do you remember from statistics class, if you ever listened to a statistics course, what quantile is telling us, what quantiles are telling us? So we said that this variable, so here, is telling us the size of health expenditures in GDP as a percentage of GDP. So this means that out of all our database, 25% of countries are spending 4.22% or less on health costs. Okay. And 75% of countries are spending 8% of their GDP or less. Okay, so this is the explanation. And this median or second, second quartile is telling us that on not on average, but the middle. So if you sort all the countries from the lowest level of expenditures to highest level of expenditures, that you will get 5.81. So this is some number that prevails when it comes to size of these expenditures on health as a percentage of GDP. And if we want to so this is data. If you look again here, so this is data through time. So I have data for each country from 2000 and mostly from 2000 until 2017, because data before 2000 is not available in a lot of countries. So if I want to calculate these quantiles for a particular year, let's say 2017, then I will filter out the data. And this function filter just gives us a subset of the data. So if you look here, I have WDI date, and if I run this row, for 53rd row, then I will get this object WDI, and you will see that this object has only 217 observations. Why? Because I only took the data for the year 2017. Okay, and you here you can see there are 217 countries from Afghanistan to Zimbabwe, and we can just check the size of health expenditures as a percentage of GDP from for these these countries. Okay, and then we can see who has the lowest, who has the highest, and so on. So max, means, and so on. And if you remember, the formula was summary. So if I write summary VDI $, my variable of interest, I will see that the minimum is 1.18 or around 1%, and the maximum is 17%. So here there is a country that uses 70% of its GDP for health expenditures, and this country is, Tuvalu. Okay, so Tuvalu here on the second place is United States, then Marshall Islands, and so on. So you can see here that there is a bunch of developing countries and one developed countries that uses 17% on health. And we know that overall healthcare in the United States is not very good, no matter that they spend so much money, so more than 17% of its GDP. And we can see, for example, in Germany, 6% less, but or 6 percentage points less. But we know that healthcare in Germany is on higher level than healthcare in United States, and we can see that there is a bunch of developed countries that are around 10%, and here obviously United States are outlier. Sorry, so here we can see that they are outlier because they spend so much, but they get in return so little. Okay, but this is the point of descriptive statistics. You need to be able to find this so to calculate it, and then to comment. For example, I commented here that United States is an outlier. Why? Because it is in a group. It is within a group of developing countries that spend a lot on healthcare, but they obtain less in return. And this is something that is like a puzzle. So the question is why? So why they spend so much and get so little in return? Okay, so this is regarding descriptive statistics. And finally, if you want to plot data, so here you have the code to do so. So if you want to plot original data, so we will use row 56. So I will run it, and then you can see here that this data is for all countries in your data set. And if we want to get some world data, so if we want to filter out only data on the world level, I will just run the row 57, and then I will plot this subset, and I will only get just a moment. Yeah. Just a moment. Okay, and just wait. Give me a sec. Okay, and here. Okay, so this is the size, or sorry, I will just increase it. So these are the expenditures on health on the world level. So I will use just type is equal to L. Okay, so these are the expenditures as percentage of GDP on the world level from 2000 to 2017. You can see that they are increasing, although so the trend is increasing. But here we have two bad periods. So first was due to financial crisis 2007-2008, and another one was again, so this is due to the crisis in Europe in 2010-2020, you know, the sovereign debt crisis and so on. So these two negative swings are due to crisis in America and later crisis in the whole world. So but overall there is increasing trend. So countries are increasing expenditures on health throughout this 2000-2017 period. Okay, so this is regarding the descriptive statistics. So I will just take 10 minutes of your time. I know that we are at the end, but I will just take 10 minutes more just to finish with Eurostat, and then I will call it a day. So the same thing that we did for World Bank can be done for Eurostat. Again, there is a package called Eurostat. Again, there is the same principle. You just highlight it, run it. So in this case, I will not install anything because everything is already installed in my case. In your case, you can see here that this stop sign just tells me that R is just trying to install it again, and now it has succeeded. I will use the library. So each time when you install some package, you need to make it available, and you make it available by using function library, and then you can work on it. So we will skip these packages because it is something that we can do, we can live without it, and it makes our life easier, but we can live without it. And regarding Eurostat data, this is a so-called table of contents. So I created an object that is called table of contents. Why? Because first, when I run this, I will get a new object. And you can see here that this object has 8 variables and has almost 10,000 observations. So these observations are actually data sets in Eurostat. So these are different data sets in Eurostat, and we can access each one of them by using this code here. So this code is acronym for particular data set. Here we have data start, data end, whether it is in years or in months. So you can see, or in quartiles. So there are different types of data. And let's say that we want to access some health data. So first I searched. So row 75 is just for the searching purposes. So this is like search engine. And it will give me all the data that have health in it, that they mention health. And then I deliberately pick the first data. So these are people having a long-standing illness or health problem by sex, age, and degree of urbanization. And then the code 77 helps me to get this data in R. So it needs to download it, and now I have this data here. And in order to extract what I'm interested in, so I want to extract only data. So if you look at this data, view data. If you look at this data, then you will see, so this is degree of urbanization, this is age group, so from 16 to 24 to 16 to 29 and so on. So there are different age groups. You have sex, either female, male, or total, so male plus female. You have units, so this is per capita, so the number of people. Geo, so this is a country in Europe, so Croatia is under acronym HR. And here we have time and particular values. So if I'm interested into Croatia, then I will just filter out the data where geo is HR and time is 2018 if I'm interested only in year 2018. So I start this, or I enter this this command, and I get data for Croatia for 2018, and then I can filter even more and find some data for, I don't know, particular age, sex, and so on. So this is example here. So if I want to get the data about females that are between 65 and 74 years old, and that and if I'm not interested in degree of urbanization, if I'm only interested in total data, then I will write here total, and that's it. And finally, you have this example for plotting. So this is how you obtain data from R, and I repeat, this is how you calculate descriptive statistics. So your assignment will be just to obtain data and just to calculate. I'm now referring to individual assignments. So your assignment will be just to obtain data and then to calculate descriptive statistics. So you need to use function summary, function quantile, and you need to plot the data, and that's it. Okay. And regarding the group assignment for 3 of you who are in my group, you will need to make a linear regression model by using the paper that I already sent to one of you. I think on Friday. So this paper is just how to not example, but this everything every variable that is mentioned in your paper, in the abstract of your paper, these variables are given as individual assignments. So if just a moment, I will just stop share for a moment. If I okay, share. Okay, do you see this PDF file? Yeah. Okay. So so I send you this paper, and if you look here, all the variables here, so proportion of people age 65 or above, openness degree, so the number of tourist arrivals, the health infrastructure, so the number of hospital beds, the number of physicians per 1,000 people, and so on. Everything that is mentioned here is actually already, so these are your individual assignment. So you need to extract this data and then to calculate descriptive statistics out of it. And this descriptive statistics is everything that we mentioned here. So everything that is here between the rows 52 and 59. Okay, so these are individual assignments. You will just need to replace this code with your particular code, or in this case, for example, if I go back to this PDF, so you'll just replace it. Yanis will replace it with this, Daniela with this, and so on. Okay, so this is your individual assignment. And regarding the group assignment for my group, so you will use all the variables that are given for the individual assignment, so all variables here, and they will be independent variables, while dependent variable will be corona cases or COVID-19 cases by countries. So if you look at the data that I shown to you, so if you look at the data, not shown, but shown and so sent to you, so you have this data here, corona CSV, and this, sorry. So these are the COVID-19 cases as of July the 8th. So you will need to merge this data set with the data set that contains all the other variables that are given as individual assignments. And here you have a code. Sorry, the code is actually merge. just to give you some merge, for example, Corona rest of the variables, okay, or let's say Corona test. So imagine that you have, so I will now run this code 9092. You can see here that R is doing something, and now here I will see in data, I will have this test object available in a couple of moments. Yeah, so now I have this test object, and now I want to do the following. So if you remember here, I want to remove, so I will remove all the aggregates from my test. And now I have the Corona file. So I have this file here. So this is data, newest data. And I have here this test file that contains the data for countries, but it has all the years. I'm only interested in the final year. So I will use 2018. So in our case, you just need to do one more filtering, and you will just write that year is equal to 2018, and then you are left out with 217 observations. So these are observations. Yeah, so soon, wait a moment. Okay, so just a moment. And now when you have this data, you just merge. And if you, test. So I will merge my test, my Corona and test files. And if I look my test file, I will see that I have what I need. So I have here my variable that I had at the beginning, and I have this, just a moment, total cases. So the total cases of COVID-19 across countries, and independent variables. So in this case, for CO2 emissions, they are not data available for 2018. So we'll skip this variable, but we have GDP data, and we have this data here. This is, I think, trade openness. So this is what you need to do. So this is only for group assignment. Okay. So for the final thing here, I would like to arrange a meeting, because I know that there is a much info to process right now. So are you available on Monday around 6 p.m.? Yeah, 6 p.m. Yeah. Is this okay? That we arrange a meeting from 6 to 7 on Zoom? Okay, just a moment. I will send you a link. I will send you a Zoom link. Just wait. Okay, just a moment. So this meeting is for group 1, but whoever has problems with individual assignment can also show up and ask questions. Okay. So this is the link. So the meeting is on Monday. On Monday from 6 to 7 p.m. and primarily for group 1. But those of you who have problems with individual assignments, you are more than welcome to pop up and ask questions regarding, or you can also send me an email with questions, and then I will be happy to answer and try to solve any issues. And individual assignment needs to be handed over by Wednesday. Because I will send you one more email, because I have email of each one of you. So I will send you today another email with the couple of more instructions that Seung asked for. So yeah, in PowerPoint. Today I will give you example how to do it. So I will send you example presentation of individual and group assignment. Okay. Yeah. Okay. So just to repeat. Yeah. Sorry, I forgot. So we can. I forgot about the time difference. So those of you who are in Korea, what is the best time? What is the time that suits you most? Is it around? Is it okay if? Just a moment, I need to see your schedule, because for me it is okay in the morning, but I think that you have some other. Just a moment. So on Monday, you have classes until, so you have classes until 2:15. So can we arrange maybe at 3 p.m.? So 3 p.m. is okay with you, but it is not okay with it is not okay with Devrim, yeah. No, Wednesday, but yeah. And what about Tuesday, 3 p.m.? Okay, Tuesday is fine. Okay, is Tuesday 3 p.m.? Okay. Okay, so Tuesday from 3 p.m. Okay, and just to write, and deadline for individual assignments will be on Wednesday. Okay. Yeah. Okay. So just to recap, today I will send you example presentation for individual assignment and for group assignment, and on Tuesday we will meet starting at 3 p.m. and the deadline for assignment will be Wednesday by the end of the day. Okay.